Hey everybody, what's going on? This is Caleb with devslopes.com, and in this video, we're going to start talking about protocols and delegates. Okay? Protocols are a really amazing feature of Swift particularly, but of a couple other programming languages. And basically what a protocol think of it like a blueprint. Okay? Now, this blueprint can contain methods or functions, properties, and other requirements that fit a particular task or like a piece of functionality. And what we're able to do is we're able to conform to a certain protocol from a class, from a structure, or even an enumeration, which you'll see later in this video. And that enumeration or that structure or that class can provide the actual implementation of the methods or properties or whatever you set in your protocol. So really cool. Let's dive into it now. You're going to want to open up Xcode Beta, and we're going to get started with a playground. Let me pull it open in the right window here. There we go. And just click blank. And I'm going to actually, let's put this in the proper folder for protocols. Let's call this Protocol Mania. That sounds fun. Press create. And here we go. Okay, let me bump up the font size a bit. And let's get rid of this. We do need UIKit. We don't need that string. And great. Okay, let's get after it. So let me start by showing you the protocol syntax, which you can use by simply typing protocol and then giving a name to your protocol. Now, it's the same thing that you would do for naming a class or an enumeration or a structure, all capital first letters of all of the words. So if there's 3 words, there's 3 capital letters. For this one, we're just going to call it number. Okay? And we're going to just be doing some fun things with different types of numbers, and I'm just going to show you how protocols can be valuable. Then we're going to do another example using some classes and a couple other things to show you how it can be used in class instances. And then in the next couple videos, we're going to use protocols as a means of delegating information between view controllers and lots of really cool stuff. So let's just begin by getting familiar with protocols in general. So inside of a protocol, you can include methods, and you can also include properties. So I'm going to include a property in this protocol called float value. And I'm going to declare it by typing var float value of type float. And if we want this property to be accessible, we can go ahead and give it some curly braces. And then inside these curly braces, we can choose to put get or get set. And that will allow us to either just get the value of the float value or be able to set it as well. But for this video, we're only going to need to get the value. And I'll show you why later. Now, let's say that we wanted to include a function as well, maybe get float value. Okay? You just declare it like this, func get float value, and you include the parentheses for showing that it's a function, but you're not going to put the curly braces. And watch what happens when I do that. Protocol methods may not have bodies. Remember the description I said at the beginning of the video, the protocol is not where you declare the implementation. Okay? Wherever you conform to this protocol later on, that's where you'll declare the implementation. And I'll show you what I mean. But for now, just get rid of this function and leave the variable float value. So what we can do with this protocol now is we can conform to it just like you would with subclassing. So if I wanted to create a square class and then create maybe a rectangle subclass that inherited from square, I could do that by typing class square, square, and then, I meant class rectangle, and I could inherit from class square. That's one way I could do it. So for protocols, it's kind of the same thing. I'm going to make an extension of float. Okay, now if you've already seen the extension video, that's great, so you'll have some familiarity with extensions. I'm going to extend the float type, and I'm going to conform to my protocol number. Now, you'll notice there's going to be an issue that says type float does not conform to protocol number. Now, remember, I said that a protocol is sort of like a blueprint, right? A set of instructions in order to set something up the right way. So what we're saying is if we conform to the protocol number, we need to include the variable float value. what we can do to do that is we can basically call float value, and you'll notice that it shows up right there in my list of properties. If I press enter, you'll see that it passes it in. But what we need to do is we need to return a certain value to this variable. So we can do that by typing return. And let's think about, what do we need to return? In this extension of float, we need to return whatever value is passed in as a float. So let's say I create a variable of type float, and I should return self to float value, right? Because it already is of type float. So that's great and all, but that basically is going to give us the ability to pull out the float value of a certain constant or variable. So like for instance, I could do this. Let for of type float equals 4. And now if I wanted to get the explicit float value, I could type 4, and as you can see, we can pull out the float value. Okay, so we've extended float to include the property float value. Pretty cool. So now let's think. If I wanted to do some math, maybe between var 3 of type int equals 3 and var 4 of type float equals 4, if I wanted to do 3 plus 4, I'm going to get an error. And the reason for that is because the types are not compatible. Int and float are not the same, so we can't add them because it doesn't know how to do that. But what we can do is we can write an extension of all of our number types, and we can give it the float value property that's going to essentially convert it into a float. Let's do that. So let's go ahead and type extension, and let's extend double, because that's one of our number types. So we're going to conform to the protocol number, and then to officially conform, we need to include all the properties. So let's go ahead and give it the value for float value. And now we need to think, what are we going to return this time? We need to return, but we need to think, if a double is coming in, we need to somehow convert that into a float. And how we can do that is by doing typecasting. So go ahead and type float, and we're going to give it self, meaning whatever double value we have, we can pass that in as self, and we can encapsulate it as a float and return that to our variable. So instead of doing 3, let's change that to a double. It's still not going to work because they're not related types. But what I can do now is I can type 3.float value, and I can add that to 4. They're now type compatible. So if I actually were to do this, it would print out 3 plus 4 equals 7 successfully, and it would be of type float because using my extension, I can now pull out the specific float value for that variable. It's pretty awesome. Let's go ahead and let's get rid of that, and let's keep extending this. Extension int not of type number, but we're conforming to the number protocol. Let's go ahead and call float value, and let's return, just like before, float. We're going to encapsulate self and cast it as a float. Next, we're going to go ahead and call extension uint, because there are many times where we will have uint values. Go ahead and conform to the number protocol, call float value, and return float self. Okay, self encapsulated as a float. So now we have 4 extensions. We can access the float value of any of these now, which is really cool. And now let's do our best to write an equation that's going to let us basically add numbers of unrelated types. So let's go ahead and let's create a variable called x, and let's make it of type double. And let's make sure that it's a double by adding some decimals at the end. Let's create another value called y of type int, and let's go ahead and make that equal to 5 because it's an integer. It must be a whole value. And let's go ahead and let q, I'm going to divide these, let q be the quotient, and it's going to be equal to x divided by y. Okay, let's see what happens. It looks like we're getting an error here. Check it out. It's saying the binary operator divide cannot be applied to operands of type double and int. Okay, so we're getting the same problem as before, but what we're going to do is we're going to write some functions here that will allow us to make these work nicely. Now, one thing we could do is we could do x.floatValue divided by y.floatValue. But what if we don't think to pull that out all the time? That might not work. So as you can see, it does work to do this. But what if we just wanted to be able to divide unrelated types? We can write some functions that are going to allow us to override how these binary operators work. Let's do that really quick. It's pretty cool. So go ahead and we're going to basically just write func add, okay? And inside of add, we're going to pass in two values, right? Value a of type number, okay? And value b of type number. And we're using our protocol there as kind of like a class to pass in. Now, inside this function, if we're adding, we're going to take value a, whatever we pass in, dot float value, and we're going to go ahead and add it to value b dot float value, okay? The only issue is that we actually need to return a value here, okay? And we're going to return a value of type float. Let's say we're just working with floats. So we can return it like so. Return value a plus float value plus value b plus dot float value. So many floats there. Okay, so that is how we can do the addition function. But what we're going to do is we're going to do this for addition, subtraction, division, and multiplication. So copy this function. Just for time, we're going to paste it a few times. I wouldn't normally do this, but just for time's sake, we're going to. Replace plus with minus, and do that again. Replace plus here with divide, and replace it there as well. And then replace this with an asterisk for multiplication, and do the same thing there. Now, we have these functions. Whenever we call plus, it's going to use it like a function. We're going to take value a, pass it in, value b, pass it in, add them together, and return the value. So now, watch what happens. I have two unrelated types, double and int, but when I use the division operand, check out what happens. It passes in these two values, and it returns a float. It works. I am able to do operations on two unrelated types thanks to protocols. Super, super cool. So as you can see, protocols are pretty awesome. They allow us to basically set a blueprint for values that we are going to use or will need to use. And this is just one way they can be used. I think I'm actually going to split this video into two, and in the next video, we're going to actually see how protocols can benefit us when using classes or structures, etc., etc. So let's go ahead and let's move over to the next video, and I'll show you how to do that right now.